Hi, everyone. We're going to look at some class notes today about alcohol, the pharmacology of alcohol. So remember, pharmacology means how a drug acts in a body. So that's what we're going to be looking at today. The effects on the brain due to alcohol, the effects on the rest of the body. So just some general facts. And by the way, you are recording notes on the note sheet that was posted on Classroom. You can use Cami to fill it in. So alcohol is the class of drugs that it is depressants. So it's a mood-altering depressant, which means that it lowers vital signs in the body. So that Kahoot that we did the other day, the first question asked if it was a stimulant. That's false. Its chemical name is ethanol, and there's its chemical symbol there. The LD50 for alcohol is about 7 grams per kilogram. So I don't know if we've talked about LD50 much in class, but LD stands for lethal dose. And the 50 represents the dosage that would be required to be lethal for 50% of a population on average. So that's 7 grams per kilogram. That means 7 grams of alcohol per kilogram of body weight. So obviously it would take more alcohol for a heavier person for it to be lethal. But on average, that's about 13 shots of liquor. So like vodka or whiskey. So hard liquor, 13 shots worth. That amount obviously would change depending on the type of liquor. So beer is not as strong. It would take more beer to be a lethal dose. So if you look at this picture down here, when we talk about one drink, there's different amounts per type of alcohol. So one beer, a 12-ounce beer, would be considered one drink. Or malt liquor is a little stronger, so it's only about 8 to 9 ounces. 5 ounces of wine, and then 1.5 ounces is one shot. That's liquor or distilled spirits. So the term binge drinking, that is when you are drinking more than 5 drinks in an hour. So one drink would be one of those options there. All right, so alcohol enters the body through the mouth, usually. It travels through the GI tract down to the stomach and then into the small intestine, and that's where it can get into the bloodstream. Your small intestine is made up of epithelial cells, which kind of look like fingers. So there's a lot of surface area on those cells where alcohol can pass over the membrane into the bloodstream. So that's why it's the small intestine where it can enter the bloodstream, where eventually it'll make its way to the heart, and then your heart pumps your blood throughout your body. So alcohol can get anywhere at that point, including the brain. That's called the blood-brain barrier when alcohol reaches the brain from the blood. And that's where intoxication starts to happen, because those neurotransmitters start firing and the effects of alcohol take action on the body. And then your heart's going to pump, your heart pumps blood to your liver as well. So the liver, once alcohol reaches the liver, that's where it starts to be broken down at about 1/2 ounce per hour. We'll talk about that later. So that process is quick. It only takes a few minutes. It takes only about 5 minutes for alcohol to reach your brain. So within 10 minutes, the body starts feeling the effects of alcohol. That time can change, though, depending on how much food's in your stomach. So that picture right there's your stomach. And if you look at the bottom, there's the pyloric sphincter. That's a little valve that you have that separates the small intestine from the stomach. So when you have food in your stomach, that closes, and it allows your stomach to digest the food, your juices to take action. But if your stomach's empty, that pyloric sphincter is open. So if you drink on an empty stomach, that alcohol goes straight through your stomach right into your small intestine because the pyloric sphincter is open. Versus if you have food, if you eat a big meal and then you drink alcohol, it's going to take longer for the alcohol to make it into the small intestine, and therefore longer to get to the bloodstream, longer to get to the brain, and it's going to take longer for alcohol to take effect on the body. So once the alcohol reaches the brain, move me up here, that's where the neurotransmitters can start either firing or being inhibited. So two big neurotransmitters in play here. There's more, but the big two are GABA and glutamate with alcohol. So GABA is the relaxation neurotransmitter. It relaxes your brain, your muscles. It's an inhibitory neurotransmitter. Glutamate is an excitatory neurotransmitter. It's responsible for learning, creating memories, brain firing, brain action. So what alcohol does is it increases the inhibitory and it decreases the excitatory. So it increases the body's relaxation, kind of makes you feel sluggish, and then it decreases glutamate. So affects the ability to learn, to create memories, and just slows down brain signaling in general. So that video that's linked right there, I'm going to have you watch it after this. It's really quick. It's really quick. It's ASAP science. I'll give you some visuals. Oh, and then also there's a release of dopamine, which is why alcohol is addictive. It acts on the reward center in the brain. So that's, and it also creates feelings of pleasure, just like an opioid does. All right, so this picture just shows other regions of the brain that are affected by alcohol and the effect on the rest of the body. So your frontal lobe is your not decision making, your emotional planning, forming ideas, making decisions. That's your frontal lobe. I guess making decisions does fall into there. So that affects, when you drink alcohol, all of those things are affected. Your hippocampus, learning and memory, your slowed senses by the cerebellum, and then the hypothalamus, which is in control of your basic bodily functions. So blood pressure, temperature, heart rate, all of those would depress under the influence of alcohol. All right, so eventually the alcohol in your body is going to make it to your liver, and that's where it gets broken down. Some alcohol actually reaches the liver before it even gets into your blood, and that's because you have a portal vein. It's a vein that goes from the stomach to the liver. So some alcohol that you drink reaches your stomach, travels through the portal vein right to the liver. So it never even makes it to the blood, never makes it to the brain. The rest of the alcohol has to go through the blood and eventually get back to the liver. And then the liver breaks down alcohol into two steps. So here are those steps right here. So we have alcohol broken down into acetaldehyde, which then gets broken down into acetic acid. And the two enzymes are ADH and ALDH. So these enzymes are in your liver, and they break alcohol down in those two phases. So that in-between phase, the acetaldehyde, that is toxic to the body. That causes headache, nausea, doesn't make you feel good. That's the hangover, the buildup of that molecule. And then once that is broken down into acetic acid, then your kidneys take over and break it down even further to carbon dioxide and water. And then you pee it all out. So liver enzymes break down alcohol at a constant rate. I think I said this before. Nothing can change that rate that alcohol gets broken down. So it's a total myth that coffee, a shower might speed up the rate that alcohol gets broken down in your body. It's just time. You have to wait it out. So if you drink a lot, your liver's constantly in overdrive. So heavy drinking can lead to cirrhosis, which that picture right there is showing a healthy liver versus a totally scarred liver. That's what cirrhosis looks like, and it's not a good thing at all. All right. So some differences in the male body versus the female body. So I can't move my video here. There we go. So that process that I just talked about, that happens in both male and female, but there's a little bit of a difference. So in the male body, males typically have less fat than females, which means that a greater percentage of their body mass is water. So you can see in males, it's about 68%. And then in females, it's about 55% of the body is water. So alcohol dissolves into water. It does not dissolve into fat. It's not a fat-soluble molecule. So if you have a male and a female drink the same amount of alcohol, in the male body, they have a greater amount of space for alcohol to dissolve in, versus females, they have a smaller amount of space. So that leads to a higher concentration of alcohol in the blood. So BAC, that stands for blood alcohol concentration. The BAC in a female rises much faster than a male when they drink the same amount of alcohol. So that's what this picture here is showing. A male versus a female, same weight, both 150 pounds. They're drinking the same amount of drinks in the same amount of hours, but you can see the female's BAC is rising much faster than the male's. And then remember, the liver it breaks down at a constant rate for both. So speaking of the liver, one other difference in males versus females is that males have some of that ADH, one of those liver enzymes, in their stomach as well as their liver. And in the liver, it's more active than women, ADH. So for males, that ADH in their stomach starts to break down some of the alcohol before it even gets to the bloodstream. So that also affects the BAC. Oh, and that's the end. Okay, so hopefully you were able to fill in the whole note guide. You can go back if you missed something, and then I'm going to have that other video linked for you to watch.